Finite Mathematics, Chapter 10, Section 3, Measures of Variation. Now, the mean, the median, and the mode are all measurements of center. And that's great, but they alone don't really tell us anything about the spread of the data. We know where the middle is, but we don't know what's happening around the middle. For example, the following data tells us how many times per week each of 3 people ate at restaurants. Okay. And if you average these, each of these 3 people over those 5 weeks have a mean of 4 times a week that they visit restaurants. But if you look at the numbers themselves, they're very different. Jill kind of varied between 3 to 6. Miguel was 4 times every week. And Cheryl, well, we had a 10, a 1, and 2 weeks where she didn't eat out at all, and then a 9. So the data itself varies quite a bit, even though they all share the same. The difference in the spread can give us information about their different dining patterns over time. So, along with the measure of center, it's also important to have a measure that describes the variation among the data in the set. One measure of variation is the range, and the range is the difference between the highest and the lowest number in the set of data. It's really easy to find, and it gives us a rough estimation of the data, of the variation, because we know how far apart the highest and lowest are, but it depends on those high and low points, and we still don't know what's really happening in between. Could all the data be clustered close to the low end? Could it be closer to the high? Is it even spread? We just can't tell. All right, here's an example. You're going to find the range for these data sets, so pause the recording, give it a try, and resume to check your answer. Okay, for part A, the highest is 120, the lowest is 0, so the range is 120. If you haven't completed part B, do it now, and then resume the recording. The lowest point is 19, and the highest is 430, so 411 is the range. Now, another measure of variation is to find out how far away each number is from the mean. And to find this, all you have to do is subtract the mean from each number. And those numbers that are smaller than the mean will end up with a negative result. Those that are larger will have a positive. These numbers are called the deviations from the mean. Now, what you're going to do is find the deviations from the mean for each of these numbers. You need to find the mean first. Pause the recording, give it a try, and resume to check your answer. Okay, so we find that we have a mean of 46 years, and what they did here was made a chart. You have the ages lined up numerically, and from each of these they subtracted 46, and you can see the different deviations. Now, to check your work, what you can do is add all the deviations together. They should always equal 0 because the positive and negative will cancel each other out. So no matter how spread out or how weird the data seems to be, when you add these deviations together, if you did it correctly, they will total 0. Now, it's tempting to average the deviations and use that as a measure of variance because it kind of gives us an idea of how far apart on average everything is from the mean. But the problem is, like we just said, if you add up the deviations, you're going to get 0 no matter what the data spread looks like. So averaging them is not going to be of help. Now, you might think, well, we could take the average absolute value and then average them. And that's a possible solution, but statisticians have come up with a different way to solve this problem. And what you do is you take the square of the deviations. Remember, squaring a number always makes it positive, and you average them, and that's called the population variance. Now, instead of averaging them, if we make a slight change, instead of dividing by the number of numbers that we have, if we divide by n minus 1 instead, the number minus 1, we get what's called the sample variance of the distribution, and that is symbolized by s squared. Now, in small groups of data, the population variance and the sample variance will differ quite a bit, but in large groups of data, which is really what we usually have when we're working with real-life situations, the difference is actually quite small. Our sample variance formula, and it's what we just talked about. What you do is you do each data point minus the average, minus the mean, You square those, and then they get added together. That's the sigma. You sum them up, and then that gets divided by n minus 1. Now, when we take the square root of that, because that was s squared, remember, we get the sample standard deviation, which is symbolized by simply the letter s. And here's what that looks like. So the standard deviation is the square root of the sample variance. Now, your calculator will give you the sample standard deviation. It's in that list of one variable stat operations. It's in that list of information they give you. And I'm going to show you what all of those mean in just a minute, so just hang in there with that. When we refer to the standard deviation from now on, we're referring to this, to the sample standard deviation, not the population standard deviation. So we're just going to drop the word sample, but that's what we mean. Okay, here's the information you're getting when you run the one variable stats operation on your calculator. Right here, the very first thing you get is the x bar, which is the average or the mean. The next thing you get here with the sigma, this is what you get when you add all the data entries together. This one here, the sigma x squared, is the sum of the squares of all the data entries. The s with the x is the sample standard deviation, so that's the one we're going to be using, is the s for the sample standard deviation. This is the Greek letter sigma, so sigma x. This is the population standard deviation. The n tells you how many data entries you have. Now the down arrow key, this will only fit on one screen, so then you'll have to push the down arrow key. The next screen you'll see the minimum data value, minimum of x. Q1 refers to the first quartile, and we'll find out what that is a little later. Actually, I believe that is in the next section. The median, we already know what that is. The third quartile value, again, we'll get to that later on. And then this gives you the maximum value of the data that you put in. So in case you're wondering, here's a little reference page to what all these different symbols mean. For right now, we've learned about the top one, the x bar, and we're concerned with the sx, the one that's the standard deviation, and the median down further, and some of these other ones will come into play a little later. This problem, pause the recording to do it, and resume the recording to check your answer. All right, so we arranged our data in columns, and we have all the times, and we're going to find the mean, and the mean was 9 minutes. And then the total of the second column is 1280. They squared it, and then they added them all together to get us 1280. They're kind of taking just a little different approach here. Rather than subtracting the mean first and then squaring it, doing it slightly different, but it still gives you the same result. We get 90.3, and then you take the square of that and you get 9.5. Of course, the good news is that you can do this on your calculator. Do not need to run it through and do it by hand like we did here. So why standard deviations? Well, standard deviations give us an idea of how typical a data point is. For example, most of the population will fall within 3 standard deviations of the mean. And we're going to learn more about this in the next section. So just something to look forward to. You've probably seen standard deviation before. A lot of times when you get standardized tests like your ACT and your COMPASS and all those things, you have a mean and you have a standard deviation involved. Now we can use a slightly modified formula to calculate the standard deviation for data that's presented in a group distribution. And here's the formula for that. Now remember, you can do it on your calculator. You'll just put it in to the list like we talked about in the last section. And the one variable stats function will give you the standard deviation. All right, try this example. Pause the recording, give it a try, resume to check your answer. Okay, here we're doing it all out by hand. Kind of hoping you're putting this in your calculator as you do it. It's really a lot more efficient. So here are our different charts. We have the frequency, the midpoint, and then what you do. So we get our mean is 3.3, and then they're following through and calculating some more columns here, the x squared and the x squared, putting it in the formula, and we get 1.1. The rest of this is some practice problems, so as you go through these, pause the recording, give them a try, and resume to check your answer.